XGBoost IDS-based detection by Arturo Gonzalez and Eric Amaro. So a few facts. There are over 1 million new pieces of malware that are around and being created each day. And to combat these and other threats, we need machine learning. It's the attack surface is getting too big for just human eyes to take care of, alerts and things like of that nature. Um, So, data suggests that 43% of these data breaches will involve internal actors, including employees, contractors, and third-party suppliers. So it's also estimated that half of the data breaches will involve internal actors are intentional, while other half are accidental. So you need some system to take care of these issues that pop up that arise. Um, and what many cybersecurity experts view breaches as a big, as the biggest threat to mankind right now. We do need a way to stop that and to leverage machine learning is the way. Currently, there's intrusion detection systems out there. What an IDS is, it's essentially designed to detect a vulnerability and an attack that's targeted to a specific network, your network. So currently, they're software-based IDS systems like Snort. Suricata is also another one, um, and it does monitor all traffic and reports findings. The goal of a machine learning IDS-based system or machine-based IDS system is that it would be imperative to drop to not having as many false positives. False positives tends to be the reason why a lot of these breaches occur, um, because it eventually becomes alert fatigue, and that alert fatigue can end up hurting your organization with your analysts, disregarding an alert that they should pay attention to. So this is where machine learning can come in and take over. So currently, there's two main methods of that the IDS uses, which is signature-based detection and anomaly-based detection. With signature-based detection, it monitors traffic and it also looks for patterns, and signatures. It's not effective in detecting new attacks. The reason being that the signature has to be in there already, and it takes too much time to implement new signatures, and to because you have to figure out the signature, you have to do a lot of different. You have to take different steps in order to get the signature into your system. Whereas with anomaly-based heuristic detection, it can detect new threats without a signature, but it's not the most effective when detecting polymorphic viruses, for example. It could be also used with simultaneously with other technologies, but it's not very efficient and it's not very accurate. The purpose of the project is to find a machine learning algorithm that will aid with the detection and prevention of the malicious attack. The algorithm that we found, we sifted through, multiple algorithms. Random forest was one that we really looked at. There's a support vector machine, but that tends to be not very linear. Or network traffic isn't linear, so you can't really group it with line. Um, but we needed something that would protect the environment, because protecting the environment is the first step in defense, and it's a defense onion, right? So we're looking to protect the first layer of that onion and really ensure that where everything's kept secure. The goal is to obviously be as positive as accurate as possible. So you want a low false positive rate. So actually, Boost was the best one that we found to complete this method, to complete this objective. Also, the Internet of Things is something that else that's causing more traffic. And Internet of Things devices tend to be not very secure. There's also, we're looking to the future here. So, there's going to be a transition the next few years from 5G to 6G, which 5G was a technology that was built on cloud computing, and it was really pushed to push more cloud computing to the environment. 6G is going to be used to push a lot more machine learning into the environment. Um, so it's gonna cause a lot of data, and that data is eventually gonna become too much for human eyes, even more than it is now. Um, so need to find you know we're gonna have to use our artificial intelligence or machine learning in order to use as a tool in cybersecurity to be able to really have that outcome of how containing our environment and having it be safe. Um, XGBoost intrusion detection systems, they are the most efficient algorithm we found out there, and they've won, a lot of CAD competitions. So it really allows us to find that efficient algorithm that we were looking for, and that's what we found after sifting through all those algorithms, the other algorithms and methods. Uh, we found that XGBoost was the best. Now we're on to data sets. We're looking for data sets that would help train our algorithm on a realistic scale. So the issue with training your algorithm for an IDS based machine learning is that it it's really hard to find the right data that mimics real world information. And that's ultimately what you want, is that you need to find the right data that mimics that real world information before you're getting attacked. So that's where the training comes in. Um, and obviously, you want to avoid the false positives to avoid that alert fatigue. Um, and we would have to find an algorithm that's accurate enough for imbalanced data, because it can be a lot more normal traffic than there is going to be anomalous traffic. But that little bit of anomalous traffic that you'll find can't be enough to take down your organization. So we consider a few different algorithms. We consider SVM, but traffic data is not linear, so you can't really split it in half. Naive Bayes, it's just hard to predict the attach with this algorithm due to the fact that with naive Bayes, you really need to have the same demographic of data points, and you won't be having seen the same demographic. Then there was logistic regression, which is simple to use, but it might be a little bit too simple and not powerful enough. Decision trees, they perform well, but they're a little slower than XGBoost was. Decision trees was the other one that we really considered, but ultimately XGBoost just we found it more useful. And then K nearest neighbor, it doesn't work well with large data sets, and it can't really deal with missing values. So our algorithm, we went to XGBoost. We found some of the pros are that it could solve almost any objective function. It can't compensate for missing values, which is great, because there might be missing packets, there might be missing data that you don't necessarily have. So that won't just cause an error, and that won't just cause your algorithm to malfunction or misread information. Uh, so it's known for its power and efficiency, um, and it's won a lot of Kaggle competitions. And the reason it has is because it's so great and so efficient. And ultimately, it's a scalable learning system, which what it does, it does almost the exact same thing as random forest, but instead of just building one tree, it builds multiple trees that correct itself. It could lead to overfitting. I mean, that's something that you always kind of run into. That's an issue that you might run into. It could lead to overfitting if the data is too noisy. That's why you have to clean your data. Um, and it has a lot of hyperparameters that can be a little hard to tune at times. But once again, we're dealing with a lot of imbalanced data here, so it doesn't you you can't really, you need these hyperparameters to be tuned. So what is XGBoost? So XGBoost is a decision tree ensemble machine learning algorithm. It's used in supervised learning, and it uses gradient boosting, the gradient boosting framework. It's just extreme gradient boosting, uh, and it's used in a wide variety of applications such as regression, classification, ranking, and user-defined prediction problems. It's very portable. It's very usable. You could integrate to the cloud. It supports many languages, so it's perfect for for any organization to implement. And as you can see here, just using XGBoost, it's very efficient, and because it's very efficient, gradient boosting does a great job in terms of predictability. But in terms of time, uh, training time, it takes it's a lot less with XGBoost. Why? Because it builds all those trees, and those trees really help you train your algorithm a lot faster. So here's some results of the coding that we did. Um, so as you can see here, we got perfect precision, perfect recall, perfect depth one score, and this is all due to the fact that our data was cleaned properly. We use a CICD IDS dataset, CIC dataset, which it has plenty of attacks. It has 25. It mimics 25 end users being attacked during the work period and during after hours. Um, so let's read through some of these numbers. Position equals the number of positive class that actually belong to the positive class. So recall, it quantifies the number of positive class predictions made out of all positive class. So you want precision recall on F1 to be closest to zero. I mean close to one. My bad. Closest to one. And as you can see here, we got them to one with an accuracy of 99.97%. Um, So some conclusions. Here's the F1 score and the recall and precision and accuracy. Here's what they've been: true positive plus true negative, divided by true positive plus true negative plus true false positive plus false negative. Precision is true positive over true positive plus false positive. Recall is true positive over true positive plus true negative. And F1 is 2 times precision times recall over position plus recall. So they all kind of lead to the same thing, which means that you want your true positive to be as positive as closest to one as possible, and that will lead to higher scores. Uh, so ensemble algorithms, they led to the best performance out of all of them, but actually Boost is built off boosting, which is an ensemble algorithm. It's based off the boosting framework, which is an ensemble algorithm. Um, and the reason why it's so great is because actually Boost is optimized to be fast and reliable. It creating boosting adds new trees and corrects previous errors. As I had mentioned, actually Boost is flexible, so it's able to be used on large data sets. It's also able to be used on medium data sets. Uh, so it has that ability to that elasticity really. Um, and it also has regularization techniques to avoid overfitting. Overfitting is a huge problem, and it can be a big problem with XGBoost as well. But that's where you need to tune your hyperparameters. So there is a lot of future to this method and to using machine learnings within an IDS. One of them is recurrent neural networks, which are currently used in NLP, natural language processing. But they also have an innate ability to hold data, which might be able to be used to generate machine learning algorithm that'll look out for novel attacks, because ultimately we want it to be able to detect any novel attacks not just attacks that are out there, because then it's same as a signature-based ideas, and in which case, yes, machine learning does do a better job, but ultimately we wanted to get to a point where it could generate a way to sense novel attacks, when they're happening or before they happen. Deep learning techniques is something that's really being sought after to improve the machine learning process. So with deep learning being a subset of machine learning, it's something that's being researched. There's still a lot of research that needs to be done on this subject, and there's a lot of research that is out there currently. But what's really lacking is the data. We need realistic data. So there's a few researchers who are working on that. One of the fields, the emerging fields, is electric cars, electric vehicles. The reason being that electric vehicles tend to be connected to the internet. So eventually that's going to be part of the Internet of Things, and that can be just another attack surface where hacker could hack into a vehicle and control its speed, control just even steal the car. I mean, I've seen that you know references to that. So there definitely is growth in this field, and there's growth in this area of machine learning, and it's going to be interesting and exciting to see what gets done and exactly how it gets done, and where this all leads. Thank you for watching.